Welcome to session 2 of the Logic Pro X Beginners course. Today we're going to deal with MIDI recording and editing. The title of the course is Digging Deeper into Editing, but specifically MIDI editing. Next week we'll do some recording of audio and some recording audio editing, but we're going to concentrate specifically on MIDI today and all the features that Logic has, which are many for MIDI recording and editing. So as always, I like to start with a quick keynote that kind of covers the agenda for today. So I'm going to pull that up onto the screen real fast. Got to get out of that for a second and change so you can see my desktop. Now maybe it'll work. Here we go. Okay, so in today's course, again, the title of the course is Deeper into Editing, specifically MIDI editing, MIDI recording and editing, to be very specific. And so what I'm going to cover today are the MIDI basics, just so we understand exactly what MIDI is and how it's different from audio. And we're going to talk about different types of MIDI controllers, ways to input MIDI into Logic. We're going to talk about different MIDI software instrument. Logic is full of great software instruments that come stock with the software. Then we're going to specifically get in how the basics of recording MIDI in Logic and how that's all set up. Then we'll go to how to correct timing of MIDI in case you're not the most perfect player who just your timing isn't great. That's fine. We have ways to fix that. We'll talk about how to join recordings into a MIDI region. And then we'll talk about recording MIDI takes. If you ever recorded audio in Logic or any software, you may be familiar with different audio recording takes where you can do something very similar with MIDI. Then we'll look at a new feature that came about in Logic 10.2 is how to repeat MIDI notes and erase MIDI notes. We'll talk about layered patches and split keyboard patches, step input recording with MIDI. We'll talk about programming MIDI, which is different from recording with the keyboard. Programming will actually just be using the pencil tool and things of that nature to draw in MIDI notes. Editing the pitch of MIDI notes, we'll look at that. And then editing note velocity in Logic. Let me continue here. We'll also talk about the new brush tool and time handles and how that works with MIDI, how to import MIDI from a different application that you start in, or maybe someone sends you MIDI over into Logic to edit and use, how to use the event list editor, how to quantize pitches, scales, and timing, and the MIDI draw feature. And then finally, we'll have time for questions and answers. Of course, I'll always look over to see if there are questions on the screen, and I'll try to answer them as they come up if it doesn't take away from kind of where I'm at. All right, so let's hop right into the MIDI basics. In order to actually use MIDI, you don't need to know a whole bunch about it specifically, but it's always good to kind of know exactly what it is. So MIDI, the word MIDI, M-I-D-I, is actually an acronym. Which stands for Musical Instrument Digital Interface. So it suggests that it has something to do with music, some type of music instrument, but it's some type of interface between two things that is digital. It's been around since 1983, which is, 33 years at this point? And it hasn't changed a lot since its inception. Really only the means of how we connect and the ways to send MIDI, but the actual technology and the protocol is very similar to what it was at its inception. So kind of the definition of MIDI is that MIDI is a control protocol that sends performance data between musical instruments and sequencers. Now, here's one of the main things that confuses a lot of people about MIDI. MIDI is technically incapable of making sound by itself. It's just basically a transcription of notes you played, knobs you turned, wheels you've moved on your MIDI controller to control a sound generating device that can receive that MIDI and transcribe those notes that you played, knobs that you turned into information to create sound based on that MIDI device. But MIDI in and of itself does not create sound. It has no sound to it. It is actually possible to successfully use MIDI without knowing anything about it. And many of you already have. I'm sure you've opened up GarageBand or Logic or some other application and started to create music, and maybe you didn't know a whole lot about what was actually going on. It just kind of worked. So you can actually use MIDI in just about everybody has. If you have a mobile phone or iPad or anything like that, and you use any type of sound in that, you're probably using MIDI in some kind of way, shape, or form also. So you are getting a basic understanding of it, and then we're going to go a little bit further, but I'm not going to spend a whole bunch of time talking about what MIDI is and the technicalities of the hexadecimal system and all of that type of things, just enough so you can use it and take advantage of it. So the key to using MIDI is having a working knowledge of music. It's a musical instrument digital interface. So the more you know about how music works and a little bit about music theory, the better off you're going to be with anything in music production, but definitely when using MIDI in a software application like Logic. So let's talk about, this is kind of the most in-depth I'm going to get with what's actually happening with MIDI, and then we'll just kind of get into the software and look at how it's all translated into Logic. First, let's talk about the MIDI data. Now, MIDI data that comes from however you're connected via your MIDI controller or your MIDI instrument to the sound generating device. And there are quite a few ways to make that connection. But today usually is USB or what I call the old school 5-pin DIN connection, which is the original MIDI connection that was created in 1983. For the most part, we send MIDI back and forth via USB, a universal serial bus cable now. And when you send MIDI information, it actually sends a MIDI message. And that MIDI message is made up of 3 essential pieces of data. So each portion of that data is assigned to a specific role. Like the first portion tells the receiving device actually what kind of MIDI message it is you're sending, or specifically is known as the status message, what it is that you're doing. Because MIDI doesn't just trigger notes or play sounds or trigger sounds. There are a lot of other things you can do via the MIDI protocol. So at number 1, you see it says the first piece of data is known as the status message. And that really just communicates to the controlling parameters from what you're sending to the receiving device. Like in our example, and we'll keep it very simple, and we'll just kind of concentrate on the MIDI note on status message. Because that's when you play a note, it actually sends the MIDI message that you played a note, and it has specifics to the note that you played. So the first thing it says is, hey, this is a note on message. He pressed the key, he's holding it down, the note is on. Now, that's the first piece of data that comes in that message. You get the status. Attached to the status, you will also have the MIDI channel that's actually being sent, that it's being sent from. MIDI can actually send 16 different channels on one MIDI connection. So when you play a note, it'll say MIDI note on channel, let's say, for instance, channel 1. Then, because it's of the status, whatever that status is, then the second and third things that happen can vary. With a MIDI note on, you're always going to have the next thing that's going to happen is going to be data byte 1. And those data byte 1 and data byte 2 are used to transmit a variety of information based on whatever that status message is. So in our example, with the note on status message, then data byte 1 would be used to indicate what note it is that you're actually triggering, whether it be a C3 or C2 or A1 or whatever that note is, and whatever octave, it will tell the receiving device, this is the note that he played. And then the second data byte will indicate the velocity of that note, or the speed at which you struck that note. Now, without getting too far into it, the speed at which you strike the note most of the time is associated with volume, but it can be associated with changing of samples and all types of other things that you can program the velocity to actually do. So the different status message, if you have a different status message, something other than a note on, then data byte 1 and data byte 2 will be different depending on what that status message is. But for simplicity's sake, we're just going to deal with note on. Data byte 1 is going to tell it what note it is, and data byte 2 will say what the velocity of that said note is. Okay, let's jump into the MIDI controllers, the actual devices that will actually send the MIDI into your sound generating device. So there are a lot of different types of MIDI controllers out there, and their primary function is to control other MIDI devices or other devices via MIDI. So, like I said, they come in a lot of different shapes and forms, like piano keyboards, drum kits, drum pads, guitars, mobile devices like iPads, iPhones, Android devices. And this on the screen is an example of an Akai MPK This is actually an MPK 61. It has 61 keys, has some drum pads, has 8 faders and 8 knobs, but it's 3 banks of 8, so you get 24 faders, 24 knobs. And then you have things like drum controllers, and drum controllers come in different varieties. The first that you see here on the screen is designed to look like an actual drum kit with pads instead of actual drum heads and snares and cymbals. So those black pads on there, those are actually MIDI receiving devices. It's kind of like keys on a MIDI keyboard controller. If you play the one that's kind of looks like the snare over there to the left, it will send MIDI information to that box that sits to the left. That's the brain, and that's where the sound is. And then you can change the sound. The great thing about MIDI, it doesn't create sounds, but it can be any sound that you assign to the receiving device. So that box could change from all different types of snares, or you can make the snare a whistle or a voice or whatever you want it to be. And it doesn't have to just control that brain or that voice device right there. You could actually plug it into Logic and use it with Ultrabeat or a Drum Machine Designer or anything inside the software. These are also types of drum controllers, but these are percussion pads, which come in a little bit more economical shape, if you will. It's not going to take up a bunch of space, can sit on your desktop, and then those drum pads are used to, in general, trigger drum sounds. But again, because it's MIDI, they can be used to trigger anything that you assign them to. The one on the left is the MPD32. It's also made by Akai, who kind of invented, if you will, well, I wouldn't say invented, but kind of are known for their drum pads on drum controllers. There were drum machines that had drum pads on it before the MPC. But Akai also made the drum machine on the right-hand side, which is the MPC 3000, a classic drum machine. Now, the difference between the percussion pads and the drum machine on the right is the drum machine actually has the ability to sample and have sounds internally. So the one on the left is just a controller. It has no sounds, no audio outputs or anything. It needs to be connected to another sound generating device or software that has sound. The drum machine can just work by itself and have sounds internally, or it can control another MIDI device or another MIDI software application, as well as it can sequence and record MIDI right into the drum machine. So you have a lot of features there. And then finally, you have non-traditional MIDI controllers. And their design can take any shape or form, and they're designed to accomplish pretty much any MIDI task you can think of, from note on to continuous controller values to pitch bend to anything. And quite honestly, they're not available for commercial release. You know, like you don't necessarily go to the Guitar Center and find a Soundscape MIDI controller surface. They're pretty much custom creations, and they're not necessarily commercially viable for a large scale release. But you can go on the internet and search custom MIDI controller surfaces or do-it-yourself MIDI control devices, and you can actually buy kits to create your own and then program them to do what you want them to do in your software. Now, these two devices I wanted to mention because some manufacturers or software manufacturers make their own MIDI devices that control specifically their software. So here you have Ableton's Push on the left-hand side. It's actually the Ableton Push 2. And you have the MPC Touch on the right. Also in the MPC family, you have the Renaissance and the Studio. And what they do is they use a custom scheme to control their own software. So the Ableton Push 2 controls Ableton Live. When you plug it up, the knobs, the pads, all the controls are automatically mapped to control that software in a proprietary way. Same thing with the MPC Touch, the Renaissance, and the Studio. When you connect them, it automatically maps to the MPC software. Now, you can put both of them in what's called MIDI mode, and then they can control they send basic MIDI note on, MIDI note off, continuous controller values, and you can assign them to anything to work with any MIDI receiving or MIDI keyboard or anything. So they can work in both ways. All right. Cool. Let's see. We got a few more people in the class. I want to welcome Francisco and Natana. I think I'm going to pronounce that wrong. Welcome, man. And let's keep moving. We're going to go ahead and open up Logic here. And